Welcome to another podcast. In this episode, we're going to be taking a look at some more limits at infinity, specifically focusing on some problems that can occur, some pitfalls of applying limits at infinity. And I want to look at two examples with you. The first example that I have in mind is to look at the limit as x goes to infinity of the function, let's see here, square root of 4 plus x squared minus x. So the very first thing you should try when you have a limit at infinity is to see if the direct substitution property is not the correct way to state it, but to see if you can plug in the value infinity and see what happens, essentially. So if I plug in infinity, which you should never really do, but that's how we're going to think about it. Plugging in infinity, I end up with something that looks like 4 plus infinity minus infinity, which is essentially infinity minus infinity. Now at this point, there should be alarms going off, bells ringing in your head, whatever the case may be. This is a warning sign. This is not zero. This is indeterminate. It doesn't mean you have an answer. It means you need to keep looking because plugging in infinity isn't going to give you the answer. Infinity minus infinity is an indeterminate form. It might be zero, it might not be. It depends on how fast the two functions are getting there. If they're getting there at the same rate, then the answer will be zero. If the two functions are not decreasing at the same rate, it might be infinity. It might be anything else in between. So you just have to work out the limit problem and then apply the limits at infinity when you have something easier to work with. So we've dealt with problems this semester that had square roots involved, and invariably when a square root is involved, we use the conjugate to simplify it, and that's going to be the same case here. So if I take the limit as x goes to infinity of the square root of 4 plus x squared minus x, the conjugate is the square root of 4 plus x squared plus x, but I need to also divide by that amount so I don't change the problem. I'm essentially multiplying by 1. Alright, if I do that and just simplify the result, then remember how we multiply conjugates. You square the first term, and then you square the last term, and so this would be our new numerator. And then the denominator is just the conjugate in this case. All right, if you take a look at that limit and do a little bit more simplifying, then the numerator just turns into 4, and the denominator is the conjugate. So now, if I evaluate this limit, once again, in air quotes evaluating, I'm not actually evaluating infinity, I'm thinking about the limit as x goes to infinity. Then if you think about this, in the denominator, you get 4 plus infinity squared plus infinity. The point is the values in the denominator are becoming very large. And there's no infinity minus infinity indeterminacy, it's all plus infinities. So the point is, the limit as x goes to infinity of this is 4 over something that heads toward infinity, which means that the limit of this is 4 over a denominator that's getting increasingly large will make the fraction small, so the limit there is 0. And I know you're sitting here saying, but infinity minus infinity, why didn't we just call that 0? And I'm trying to tell you right now, if you do that, you're going to mess up a lot of problems because that's not always true. It just happened to be true in this case. So let's look at another example. Let's look at the limit as x goes to 2 from the right of the function natural log of x squared minus 4. It's at this point that I feel the need to remind you that when we looked at the natural log, we talked about its limits and its behavior. And one of the things that we decided in a previous video was as the natural log goes to 0 from the left, or from the right, so the limit as x goes to 0 from the right of the natural log was negative infinity. So that's going to play an important role here. So when I look at this, I'm looking at the limit as x goes to 2 from the right of the natural log of something. And what we have to think about here is, okay, that something in and of itself has its own limit. So remember the way that the limit laws work is I can pass the limit inside the function. So that's what I'm going to do. So this is equal to the natural log of the limit as x goes to 2 from the right of x squared minus 4. Now, evaluating this limit is very simple, but we have to be careful. If you evaluate the limit, you get 2 squared is 4 minus 4, you get 0. And the temptation is to just say it's natural log of 0. But the natural log of 0 is undefined. There is no value for that. So we have to be talking about a limiting process here. Where are we approaching 0? Are we approaching 0 from the left, in which case the limit wouldn't exist because there is nothing to the left for natural log? Or are we approaching the limit from the right, in which case the idea would be that we'd have negative infinity for the limit as I have up here. So the point is x squared minus 4 as x goes to 2 from the right, this quantity approaches 0 from the right. And one of the notations that we'll often use for that is when we know that limit is a one-sided limit, rather than just write natural log of 0, which the limit is 0, because we approached 0 from the right, I write natural log of 0 plus. Which is another way of saying that this is the natural log that this problem is equivalent to, I should say, asking you what the limit as x goes to 0 from the right of the natural log of x is. Both of these give the value negative infinity. So the limit as x goes to 2 from the right of the natural log of x squared minus 4 is the same as the natural log of 0 from the right, which is the same as the limit as x goes to 0 from the right of natural log. So the answer here is negative infinity. If you were to graph the function that we were asked about in this problem, it looks like this. So it's on both sides, and you can see on both sides heading toward 0 from the right, you go to negative infinity. Heading towards 0 from the left, you also go to negative infinity. So in either case here, the problem is heading toward infinity. Because this is squared, in both cases, you'd be heading from 0 from the right when it's talking about the natural log, even though the limit's from the left for x squared minus 4. All right, this is just a way that you can use those limits that we talked about in the previous video to help you figure out the limits. But to be honest with you, one of the best ways that you can do this is to graph it. So graph the function natural log of x squared minus 4 and make sure that you have things going in the right direction. The same thing can be said for the square root function we did before. All right, thank you for watching.